Okay, so this video is going to be another nerd rant moment. When I try to search anything, when I get on my Chrome browser on my iPhone and try to Google anything, I get an AI response. Like, instead of just like a list of search results, it's like it will give me like this AI summary trying to answer my question, which I didn't really ask for, and it's kind of annoying the way AI is so in our face, whether we like it or not. Because I remember just liking regular search results. But anyway, so I started a small project. There is a weak spot I have in my assembly programming, and generally in programming specifically, like no matter what programming language, getting user input and processing that the right way has always been one of my weak spots in programming. Most of the time I'm writing an integer sequence program, or I'm writing a program that will use the command line arguments to get the data to do some kind of task. And these things are quick, they're effective, and it works. And that my entire DOS assembly book that I published never really used keyboard input. It used command line arguments, which were a little bit difficult to set up. But I've always liked the command line argument interface. This idea that you type the name of a program and the arguments after that, and the whole behavior of the program is controlled by that. I like that. And the reason I like that is, first of all, it's like you have a task that you need done, and the command name and all the arguments have all the data you need. So why would somebody ever write a program where you have to accept input from the keyboard during the execution of a program? Well, here is why. I finally came up with a use case for why I would need to do this. So, because of the fact that I started programming by cheating at video games, I'm very familiar with the concept of having one program that opens up the memory of another process and modifies that program while it's running. And I referred to this in my Linux book that I'm currently writing. So here's the issue. So while cheating at video games is fun and modifying other programs is fun, the problem is if I try to describe how to cheat at any specific game in my book, then I could get sued by the developers of that game if it's a closed source proprietary game. Now, it's also possible to hack some types of open source games, which is, of course, not really needed because you can get the source code and change the game in any way you want anyway. So here's what I actually needed is I'm trying to write an assembly language program that it keeps going until the user presses exit, until they enter exit as a command. And I had a function named Getstring in chapter 8 of my Linux book. And it's an actual example where the user keeps entering a line of text, and then it will then tell you what the string is that you entered and how long the string is, the string length. So it was just a very basic program to accept user input, and it keeps running forever until the string entered is exit. And it has to be exactly exit. It can't just contain the word exit, but the entire line has to be exit. So it's a valid program. It has a way to, the program keeps running and then it pauses every time it waits for a keyboard input. And the way it's implemented is actually pretty simple. But here's the issue. The issue with getting user input from the keyboard is that sometimes you want the entire line of text to be a string, which includes all the spaces or any other things like tabs or whatever. Other times you want the string return to only be the first word or first or second word, of a of string. Because if you think about command line arguments, you have, the program name and then space, the first argument, space, the second argument, space, the third argument, that kind of thing. So if somebody wants to write a program that processes keyboard input from the user, but then processes individual words or parts or tokens of that line of text and operates with those, well, that's a very different thing than operating on the entire string with the entire line of text. So really, you need two functions. And for example, Getstring would probably just be get, the next word of a string and terminated by a white space, basically. The other one would be called getLine, which gets an entire line of text and returns that as the string. Now, the AI response I got in my search result is it was describing the difference in C++ between the getLine function, which is a getLine function that exists in C++, which I'm not using. I'm using assembly, but it has that behavior that I'm describing. And then it also describes how if you just read from cin into a string, it will just get one word of text. So it'll skip any white space, get the printable characters as a string, and then it terminates at the next white space, which is a very useful feature, especially for C++ programmers. But in assembly, I have to implement everything myself. So basically, here's what I have to do. I have to overcome my weakness when it comes to getting user input. And here's the trick to it, is that basically, I have to write another library, because the chaselib library that I've been using in C and assembly that I've been writing it consists of 4 core functions. You know how it'll have, put string, put int string, and string int, and then of course in the assembly version I also have like a function for put char, for example. Because that's not a built-in function in assembly language, I have to simulate the C function of put char. So I have some additional functions like put line or put space, that kind of thing, just because it saves my coding. It saves me time and saves me disk space for my programs written in assembly language. So it's very efficient. But everything in that library is all about either converting between integers and strings, or it's about outputting those integers and strings. So it's entirely output and conversion focused, which is a very valid library. But now I have to have the counterpart to it. I have to have a library that has these useful functions. And here's what I'm thinking. Just as there are 4 core functions in the first library, there might be some extras, but there's the 4 core in that library. There's going to be 4 functions in this new library that I'm doing, and they will be getString, just get a word of text, terminated by the next white space character read. getLine, which gets the entire line of text and returns that as a string, and then there's going to be 2 other functions. There's going to be string length, how do you say string length, or string length. It's an abbreviation, just like the C function. See, I already have written strlen. I've written that one that gets the length of a string, and then strcmp, which is string comparison. I've already written those functions. Those functions have already been written, and they are used in a few of my programs already. But what I've been doing is I've been copy pasting them from one program to the other, so that whenever I update one program function, I have to copy paste to the other. Now this is unsustainable, because I have this one program, chase text, which transforms text, so it has to have string comparison to compare whether strings are equal or not. And then I have chess stack, which is my stack-based calculator featured in chapter 10 of my Linux book. So basically, here's how this works is I've been copy pasting these functions between these two programs, but I need a common source. I basically need to have a separate header file for getting user input. Sometimes I would use it and sometimes I would not, because basically there are some programs where you're accepting input from the keyboard and there are other times when you're just outputting things. So it's going to be the second library. So basically, I like this idea though. The reason I like this, of having two separate libraries, one for output and one for input, is that basically allows me to have two header files for two different purposes. And 2 is my favorite number because the binary numeral system and electricity, on and off, 0 and 1, up, down, left, right. You know, everything comes in terms of 2. Some people would even say male or female. And that is a whole thing right there. I could say there's 2 genders, but then some of us have multiple bits where some of those bits are male and some of them are female. Like the binary numeral system applied to gender identity is really not that hard to explain. I don't find that hard to explain at all. You know? In fact, I'm gonna say something here. While I'm having a nerd rant, I'm about to say something. Saying that a person is either male or female, you're either or, you're only one or the other, is like saying that a checkerboard is either black or white, but a checkerboard is both. So I have just explained checkerboard gender, and I should copyright that, like totally. Checkerboard gender is where you're black and white, and transgender identity is where you're male and female, different parts of you in some ways. Your mind is one way, your body is another way. Like, it's so easy. It's as easy as the binary numeral system, and that's just how I view it. Like, why is this so hard to understand? And considering the high number of transgender women who are also computer programmers, you would think this would catch on more. That's just my opinion on the matter. Thank you for listening to my TED Talk on computer programming and the functions I'm going to write and checkerboard gender. Now, I need to get to work and focus on work. And I don't want to, because I want to go home and write my programs and functions and my entire assembly language library. That's all I care about right now. I don't care about Walmart, but I have to work all night.